काश्यपान्वय संजातं नारायण पदाश्रितं श्रीमन्नारायणं वन्दे यतीश्वर श्रियाजुषम् ॐ नमः परम ऋषिभ्यो नमः परम ऋषिभ्यः ॐ नमः परम ऋषिभ्यो नमः परम ऋषिभ्यः ॐ पूर्णमिदं पूर्णमदः पूर्णात् पूर्णमुदच्यते पूर्णस्य पूर्णमादाय पूर्णमेवावशिष्यते ईशावास्यमिदगुं सर्वं यत्किञ्च जगत्यां जगत् तेन त्यक्तेन भुञ्जीथाः मा गृधः कस्य स्विद्धनम् ज्ञानानन्दमयं देवं निर्मलस्फटिकाकृतिम् आधारं सर्वविद्यानां हयग्रीवमुपास्महे ॐ अस्मद्गुरुभ्यो नमः जय श्रीमन्नारायण. I'm going to mute everybody all and Srinivas, where is Srinivas? Srinivas, can you unmute yourself?
Okay.
You are co-host, right?
I think so. Let me see.
Okay, I did now.
Okay.
Yeah, please go ahead.
So, can you see the screen, PowerPoint screen?
Anybody just show your thumbs up? Okay, yeah, they can see it.
Namaste everyone. Welcome to Vedic Math knowledge sharing session with pravachanam.com. Srinivas Ramanujan Mathematics Club actually jointly presenting this. Before going further, I wanted to thank my guru first, and then Bharati Krishna Tirji. He's the one actually brought this Vedic mathematics knowledge to this world. I wanted to pay my gratitude to him. And then during my journey, starting 2004 till today, I met so many and very knowledgeable people in Vedic mathematics area, and some of them are researchers, some of them are practitioners, some of them are just learning things like that. I mean, like I met so many, and I learned from each and every one of them. So I thank each one of them. First, I would like to say Sai Kiran. Actually, I met him actually in 2006 or 7, that time frame, for the first time. And he is the only person actually I met him in person. But after that, I met so many others like Richard Blum from Florida, and then Kenneth Williams and James Grover. These two are from UK. And then I met Mucham Reddy Garu, one from Hyderabad, and then Satish Ji. He's also very knowledgeable in Vedic mathematics, and not only that, he's actually, he Sanskrit. I don't know much about Sanskrit. I'm just learning. So that way I feel so proud of him. I need to learn lots from him as well. So um, without delaying, actually, my usually, I mean, my presentation always um, focuses on, explaining the fundamentals in a deeper way, so that they never forget it in lifetime, and then that really helps them in whatever they do in their future, rather than telling complex things and telling about calculus or statistics and all those things at higher level. It really doesn't make much sense at the, I mean, in 1 hour presentation. So actually, I wanted to touch most of, like, I'm actually touching 2, 3 different Vedic math sutras. And then each sutra, actually, how we can extend it in different dimensions. That is the idea behind this presentation. So let's, before going further, actually, I wanted to tell a little bit about Bharati Krishna Tirthaji. Um, I think many of you can browse and you can get lots of information about him in internet. But I wanted to tell some important things which actually made him unique. As most of you know, he is actually Sankaracharya from Puri, Govardhan Mutt. And then his achievements, if we take, at the age of 16, he was awarded Saraswati Award by Sanskrit, some Sanskrit group based in Madras or Chennai currently. So that is very, very rare, event happening at 16 years age. So he was so proficient in Sanskrit. And not only that, actually, he's very good at so many other subjects. At the age of 20, actually, he did masters in um, 7 different subjects. Actually, he did his masters from American University of Sciences, Rochester University, New York. And then he completed all the 7 masters in various subjects, and achieving the highest honors. I think that record still, I think, is a record, I guess. I think nobody broke that record, I guess. So some of the subjects being Sanskrit, philosophy, English, history, mathematics, science. These are some of the subjects. Um, so which shows his caliber, like, how knowledgeable he is. And then what happened, he studied Atharvan Veda, and then he spent 8 years on that particular subject, and then he framed 16 sutras, 16 different sutras, and then some sub-sutras. So he wrote 16 volumes of books initially, but unfortunately, the treasure, whatever he provided, that got lost, and it couldn't be, they couldn't recover that particular treasure. So again, before leaving his body, after 1956, he wrote, a brief introductory volume, which currently is available. Of course, if you want, you can Google, and then in Amazon also, I think it's available. This is the book. Says like this: Vedic Mathematics by Bharati Krishna Tirthaji. Probably, I think we can provide these pictures or something in our shared documents. So you can order that. And there are so many other authors basically taking each form sutra and then expanding it, and then doing research on that particular sutra and how they can be used in different areas like algebra, geometry, trigonometry, or plane geometry, like coordinate geometry, calculus, and the different areas. Basically, how we can use that particular sutra. So that information, when I mentioned about Kenneth Williams, James Grover, and all these people from UK, they are doing the research work, and they, published so many books on each one of the formulas. Like, I wanted to show some of the books. Like, so this is basically based on vertically and crosswise, vertically and crosswise. This is called Urdhva Tiryagyam. That is the sutra. So similarly, I mean, there are so many books based on, on calculus. There is another book like this. Okay. So art of calculus. So how we can use Vedic mathematics to achieve, faster results, and then bring confidence in the student. So that is the goal behind this. Um, So let me tell you about our Vedic system, our Gurukul system, a little bit, and then probably we'll go further into our presentation. Our Gurukul system actually is a special system. I think if you read about our Gurukul system, basically to certain age, like up to 10 years or so, the students always used to chant something, but they never used to learn mathematics as it is. So what happens, they used to teach some, slokas or poems or something. And then, once they learn all those things, at a certain age, they used to tell how to, use those poems as slokas to learn mathematics. So those poems actually used to have encrypted information within those. And then each syllable in that, each alphabet is actually meant for one particular digit. And then each digit actually, when you write down for that particular poem or sloka, it actually reveals some information about it. So even, for multiplications, like, if you are dividing a number by 13, sometimes it's very hard. But if you know the multiplicand and if you know how to multiply, using Vedic mathematics, that becomes so easy. So to remember, the 6 digits after decimal place, the multiplicand for 13. So they used a formula, simple a sentence. But when you see that sentence, it looks like, they're telling some story, they're telling about some person, something like that. But in reality, if you analyze that and if you write down the numbers, then we understand what exactly that means. And similarly, there are some poems which actually looks like praising Lord Krishna. And then when you decode it with the digits given for each alphabet, then you see the pi value within that. Like that, I mean, I'm going to show some examples during this presentation. Um, that is a brief introduction about Gurukul system. After that, actually, we started learning from different countries, influence on India. And of course, they started using a different way of learning things. And then, we started doing everything in a different way. So now we got used to that kind of system. And then when we need to switch to, again, our Vedic system, I think it's really, really hard. And many people actually, they think, switching from the existing system to that, it's actually, shaking for them. Like, they cannot immediately take it. But I mean, it requires lots of practice, but it's very, very useful and brings confidence. And another thing I wanted to say here is like, many people think like, it's mathematics. So whenever you learn Vedic mathematics, you are going to excel in mathematics. Not only in mathematics, but their thinking pattern actually changes if you practice it for some time. I mean, I can say I'm one of the examples for that. because when I started practicing it from 2004, and then I see the results actually now. Because as Satish said, like I write poems, I write I mean, I teach Telugu, my mother tongue, and then I teach Vedic mathematics and so many other things. How can that be possible for a person, like within that short duration? It's actually, all Guru's blessings. And then, of course, when you practice sincerely, I think you are going to achieve this. This is actually underlying current for getting all this knowledge. It's not my knowledge, it's not my credit, but I sincerely practiced, and yeah, I sincerely request you to do the same thing if possible, and then you can see the benefits sort of. Now coming to the next thing, I wanted to, always I start with some puzzle or something, and then from that puzzle, usually I teach something like which is relevant to mathematics or some other thing. In this particular scenario, I'm going to show you this block puzzle. I think many of you may know this, but in this actually we have 5 blocks. Starting from first block, we have 1, 3, 5, 7, and all odd numbers. Second one, we have 2, 3, 6, 7, and that's it. So the puzzle here is like, you can select a date, from 1 to 31, 31st, 1st to 31st, any date. And then once you choose the date, we'll ask, which blocks that particular number is existing. Suppose if you said like, second and fourth, this one and this one, if you, can you see the mouse?
Srinivas, I can play with you for them to understand
Okay.
it. Okay.
Perfect. Yes.
So I'm not going to tell the date anyway. So I chose the date already. Tell me, that date is there in the second block and third block and fourth block.
Okay, it's 14.
Perfectly right. One more time, I'll do it. Okay, yeah. I choose the number which is there in first block and third block and fifth block.
Fifth block. Okay, it's 21.
Right.
Yeah.
Thank you.
So I apologize all the participants. Initially, we thought we make it interactive session, but now I think look, if within 1 hour. I mean, if we make it interactive session, I think I cannot cover much. So I thought of just showing this, and then probably I can show you how to build this. These blocks for the kids. Elementary kids, they can create their own 5 blocks, and then they can play with their friends. I'll reveal actually how to do this, and it's not that difficult. But once you understand that, how actually I'm relating that to binary system, and how we can teach kids, the binary system and Boolean algebra and all these things. So that is where actually I'm taking you to. So now coming to this, we played 2 times, and I told the answer. So I think most of you, I think, know this, but even if you don't know, I'm going to explain. So don't worry about it. So how to construct these blocks? Okay. Prior to that, okay, let me tell the solution. How we do this. Basically, first one of the questions Satish said, like first and third and fifth. These 3 blocks are having first, third, and fifth, right? These 3 blocks are having that particular number. So what I do is I take the top left corner number. Okay, here we have 16 in fifth one, and then third one we have 4. So 16 plus 4, we had 20. And then the first one, we have 1. So 1. 20 plus 1, 21. So that is the answer. Suppose if it is there in only second and third, for example, second and third. Then if you take second one, we have 2. And then third one, we have 4. 2 plus 4 is 6. So 6 is the number having in these 2 cards, but not in the other 3. Okay, you can verify that. 6 is not there in this. 6 is not there in this, 6 is not there. So that clear. So how to build this block, these cards? Okay, let's see how to do that. So then you can do it, do you on your own, and then you can play with your friends. Now you know the solution, right? So let's see. We have 5 cards here. You need not have 5 cards all the time. You can have 4 cards, you can have 3 cards, you can have 7 cards. That depends on your interest and your patience. Okay, 5 is actually, we made it more reasonable because it should not be too easy to guess it, or it should not be too difficult to guess it. So that's why we selected 5. And that to 31. Here actually it comes up to 31, up to 31 number. So that way we can use our dates. So that's why we chose that. But the rule here is like, if you're taking 5 cards, always 2 power 5 minus 1. That is the highest number. 2 power 5 minus 1. 2 power 5 is 32 minus 1. Suppose if you choose only 4 cards, then 2 power 4 minus 1, you get 15, up to 15 maximum. And then if you select 7 cards, 2 power 7, which is 128, minus 1, which is 127. So maximum number you can see is 127. Okay, like that. So now coming to this, we have 1, 2, 4, 8, 16. These are all powers of 2. Okay, 2 power 0 is 1, 2 power 1 is 2, 2 square is 4, 2 cube is 8, 2 power 4 is 16. So like that. So suppose if you want 3, how do you get 3? Simply adding 1 plus 2. 1 plus 2, when you add, you get 3. So we need to put 3 in both the cards, like this. Okay. We put 3 in both the cards. Now coming to 4, we already have 4 there. But if I want 5, how do I get 5? 4 plus 1, that makes 5. So you need to put 5 in this card, both the cards. So that becomes, 5. And then similarly 6. If you take 6, 4 plus 2 is 6. So you need to put 6 here and 6 here, not in the first card. And if you take 7, that is 4 plus 2 plus 1, which is 7. So we put 7 in all the 3 cards. So that is one cycle. So if here actually we used 3 cards so far. We didn't touch 4th and 5th, right? 3 cards means 2 cube, which is 8 minus 1, 7. So that is why you found 7 is the highest number in this. Now coming to next step, we can take up to 4 cards. If you take 4 cards, you can fill in the other ones, like 8. 8 already is there. 9 if you want. 8 plus 1 is 9. So you put 9 in these 2 cards. If you want 10, 8 plus 2 is 10. So 10 in these 2 cards. And then if you want 11, you need to put all these 3 cards. Like, 8 plus 2, 10, 10 plus 1, 11. So we need to put in 3 cards like that. So keep on doing that. So for third cycle, if you use 4 cards, 2 power 4 minus 1, which is 15, that is the highest number. And then if you keep doing it, you can get all the 5, 5 cards. So that is how you can construct. I think you got it. If you have any questions, you can just, send a message in chat box. So we can discuss that. Now, how do I switch to Boolean algebra or binary system? How do we do that? So in this, if you take these things, Satishji told like 1, 3, 5. These 3 cards is having that number, right? 21. So those 3 cards means actually we can write 1, 0, 1, because wherever you have that, you need to put 1. If you don't have that number in a specific card, you need to put 0. If it is there in a card, you need to put 1, like that. So in this 1, 0, 1, 0, 1. Okay. So always we need to go from higher number to lower number, like this. So here actually this card is having, so we put 1. This card is not having 0, 1, 0, 1. So we have 1, 0, 1, 1, 0, 1, 0, 1. So when you convert that into decimal system, what do you get? I think if you know that, we need to write, like in a decimal system, how you write ones, tens, hundreds, thousands, like that. In binary system, we write ones, twos, fours, eights, 16s, 32s, like that. So if you write that way, we need to write 10101, and then right above that, we need to write 1, 2, 4, 8, 16, like that. So then what happens? We need to multiply corresponding digits and then add them. So first 1 times 16, you get 16. And then second one is 0 times 8, which is 0. Third one is 1 times 4, 4. Fourth one is 0 times 2, which is 0. And last one is 1 times 1, 1. So when you add up all these things, you get 21. So that is how we get it. Okay, so we can convert this into binary system. The basic thing here is like, in binary system, we use only 2 digits, either 0 or 1. We don't use any other digits. So 0 means not existing, 1 means existing, like that. So many times actually they give examples like, turning a switch on off, like that. Or we can use it in different areas. Also, we go for on that a little bit later. So binary system actually is I already mentioned about that. We use 0 and 1, only 2 digits. And similarly, we have hexadecimal, octal, and septal system, and so many other systems. Depending on the requirement, we use those systems. For example, if you take our weeks, we have 7 weekdays, 7 days of a week. So a septal system is very useful for finding, finding what do you call, like, specific date and month and year. If you give what day it's going to be, for that kind of thing, septal system is very, very useful. Okay. So every after Sunday, Monday, Tuesday, if you go up to Saturday again, Sunday starts. So that is a 7 step cycle. So actually 7 after 7 days again the same thing repeats. And similarly, octal system, we use digits from 0 to 7. So 8 digits, 0 to 7. And similarly, hexadecimal, we have 0 to 9, and then we use A, B, C, D, E, F. Those are the additional digits, because we have only in decimal system we have only 10 digits. But how do we get 16 digits? So we use A, B, C, D, E, F. So that way we can use hexadecimal system. These things probably, I think, elementary students may not get it at the moment. But once you go to middle school or high school, then you can realize, like, what you learned now. That information you can understand at that point. Now coming to, I don't want to give much details on this. Now let's see how to convert a decimal number into binary. This one actually, whoever learned in India, or 10 years ago, probably they used to teach these things. I don't know whether they're teaching now in schools or not, but this is how we need to do. We need to divide 25 by 2, and then we get 12 and remainder 1. And again, we do divide the 12 by 2, and then we get 6 and remainder 0. And again, we divide that 6 by 2, we get 3 and remainder 0. And then again, 3 by 2, we get 1 remainder 1. And then again, we divide that by 2, get 0 and 1. Whenever you get 0 as a quotient, in that case, actually, we need to write the decimal. We can write the binary number like 11001. It's actually, it's bottom to top, not top to bottom, because we always get 16 play. I mean, like ones, tens, hundreds, thousands, 10,000s. We always take most significant one, 10,000, and then we write 1,000, and then hundreds, hundreds, and then tens, and then units, like that, in decreasing order. So the same way here also, this one corresponds to 16, this one corresponds to 8, this one corresponds to 4, this one corresponds to 2, this one corresponds to 1, like that. So we always write bottom to top, like that. So this gives 25 value, 25, this is base 10, 25 base 10 is equal to 11001 base 2. So suppose if you want to convert this into decimal, we need to write 1 above the 1, and then 2 above 0, and then 4 above this 0, and then 8 above this 1, and then 16 above this 1. So 16 times 1 is 16, 8 times 1 is 8, 16 plus 8 is 24, And then this is 0, this is 0, and this is 1. So 24 plus 1, 25. You get the decimal number like that. Okay, so that is what actually is being explained here. We need to write, like in decimal system, how we write 10 power 0, 10 power 1, 10 square, like that. In binary system, we write 2 power 0, 2 power 1, 2 square, 2 cube, like that. So when you write it that way, in binary system, we get it this way, like 11001. That's what just I explained. So we get 1 times 16, 1 times 8, 0 times 4, 0 times 2, and then 1 times 1, which gives to 25. So 11001 is binary, is equal to 25 decimal. Okay. So now, how to convert a binary number to octal or hexadecimal? This one, I think, in computer sciences, we use binary numbers a lot. So if you want in octal system or hexadecimal system, many people actually, they convert into decimal system, and again they convert into octal. I mean, that is how actually we learned in school system, but which is not required as such. The simple way is like, if you take 2, that is 2 power 1. If you take 8, that is 2 cube. If you take 16, that is 2 power 4. So based on the exponent, we can tell that many digits actually we need to consider to convert it into octal or convert it into hexadecimal. Okay, let's see an example here, then we can understand. Suppose if you take 97, if you convert that into binary, we have 11000001. This is what we get. But if you want to convert this into octal, you need not divide this by 8 and find out, or you should not, you need not actually convert this into decimal system and then again convert into octal. That is not required. Simply what we do is, because we are requiring an octal system, that is 2 cube, we need to take 3 digits from right to left, actually, three digits group up, and then we can find the solution. See, suppose if you take this binary number, and then if you want to convert that to octal, we don't know 97. Actually, I gave an example here, but we don't know what, when you convert to decimal, what you're going to get. If you don't know, then simple way is like, from right to left, take 3 digits and put a mark. Okay, as I put a pipe here, and then you have 100, another pipe after that, and then 1. So now each group actually can sum up and get the value. If you take the units place here, 10001 means basically you have ones, twos, and fours. Ones, eights. This is wait a minute. This is binary number, right? So ones, twos, and fours. We need to put ones, twos, and fours. Twos and fours, anyway, when you multiply, they're going to become 0. And then 1 times 1 is 1. So that's what we wrote here, units place. And then coming to 100, again, ones, twos, and fours. Then you get 4 times 1, 4, and the rest, the number is going to be 0 plus 0, so 4. So that is what I put in tens place. We cannot say tens place, eights place in this case, because it's octal number. And then if you take 1 here, there is nothing to evaluate here. So simply we put 1. So 141 is the octal number for this binary number. Okay, suppose if you convert this octal number into decimal number to verify whether that is equal to 97, simply write 1s, 8s, and 64s. So 64 times 1 is 64, and then 8 times 4 is 32. So 64 plus 32, which is nothing but 96. And then 1 times 1 is 1. So 96 plus 1, 97. That's what you get. Hope I think that is clear for everyone. Okay, this is one way of thinking about our binary system and decimal system and other systems. Okay, so a hexadecimal system. How do we do that? Let's say I gave an example here for 225. Take 225 base 10. That comes to 111000001. That is the binary number. Suppose if someone gives this binary number and asks you to find the hexadecimal number for that, then many times actually we we struggle for that. But if you think properly, 16 means it's 2 power 4. The exponent is 4. So we have we need to group up 4 digits and then bring up, hexadecimal number. So this particular binary number, I divided into a group of 4, starting from right to left. So you have 0001 and 1110, like that. So 0001 means actually these all actually become 0, and then 1 times 1 is 1, so you got 1. And then if you take the left part, here actually have ones, and then you have twos, fours, eights. So 8 times 1 is 8. And then 4 times 1 is 4. 8 plus 4 is 12. 12 plus 2 is 14. 2 times 1 is 2, 14. 14 means 14 means E, right? 14 means E. So E1 is the hexadecimal value. So if you have 15, then F. If you have 10, that is A, like that. Okay, so now coming to the other things, how do we use this knowledge, this binary thing in poetry and then music and other areas? Okay, poetry, I started writing in 2014, and then finally, first 4 years, I think it went, in slow pace, and then I used to make lots of mistakes. And then currently, I mean, I'm able to write certain things with chandas. Chandas is basically, again, one of the shadangas. You say shadangas means we have 4 Vedas, namely Rigveda, Yajurveda, Samaveda, and Atharvana Veda, 4 Vedas, right? And then we have, after the Vedas, we have Vedangas, those 6 Vedangas. Those are actually, Chandas is one of them. And of course, astrology is another one. And then Kalpa, Nirukta, and Vyakarana. These are all actually, 6 different uh, shadangas. Shad means 6. Shad means 6. Shadangas means 6, divisions. So these 6 actually are basics. Those are very important to learn to understand Vedas, because in Vedas they use lots of grammar, lots of this kind of uh, what do you call chandas and all this. Because if you take any chantings like Vishnu Sahasranama, or if you chant Bhagavad Gita, or if you chant something Rudram and all this, I think you might have heard about Anushtup Chandaha, or you must have heard about Gayatri Chandaha, something like that. So those are all actually chandas in Sanskrit. And in Telugu also we have lots of different um, Chandoritis are there, like like Utpalamala, Champakamala, Shardula, Mateva, and like that. So these are all actually, based on certain rules. We need to write poems. We need to follow the rules, um, and then we should not deviate from the rules. Um, Suppose if you take some ancient poems, we can say like it's having 2 different things in that, the poem division. Like one actually, called Dirga, the other one called Haswa. Haswa, or, lower note. Like we can say Rama, if you say Rama. So Ra is actually, that is called Dirga. Actually, we are extending that more than one, like, what do you call, um, like when you close your eyelid and then open, how much time it takes. If you can complete, that is called matra. Basically in Sanskrit it's called matra. If it can be completed within 1 matra time, that is called laghu. And if it is more than that, we call it as guru. So every, I mean, poem or anything, we I mean, consists of laghu and guru. Like, based on that, the chandas actually has been framed. um, Suppose if you take Vasudeva Sutam Devam Kamsa Chanura Mardhanam, if you take that, it is, it's actually written in a certain way, like um, um, how do I explain this? Vasudeva, Vasudeva, Vasu. That is actually Lagu Lagu. And Deva, they actually, that is Guru, and then Va. Like that, Lagu, Lagu, Guru, and Lagu. Like that, I mean, we get, patterns. So for each chandas, it's having a number of characters restriction, or how many like laghus should be there, how many gurus should be there, like that. We need to have certain rules. So that is why, I mean, it's very important in poetry, the binary system. And then nowadays, I think they are using some software, they are developing software where, I mean, when you key in the poem, it checks and tells you like whether the chandas is correct or it's having some mistakes in that, like whether that yati maitri, there are so many concepts in that yati prasa and so many things. I don't want to go in depth in that, but when you when that particular software checks for that, and it says like, yati is not properly done, or prasa is not correct, and then we can correct it that way. I mean, we can use it. And then music, of course, we have 7 notes. Everyone knows this, who are maybe learning violin or mridangam or something, like they all know. I'm not expert in that area, so I cannot give much information about it. But I know in music we have 7 notes, and if you take each raga, that consists of certain notes, not all the 7 notes. So if that note is existing in that particular raga, we can say 1. If that note is not existing, we can put 0. So based on that, sa, ri, ga, ma, pa, da, ni, these 7, right? So each one of them we can say a digit like 1 0 1 0 1 1, something like that. So that specifically says, okay, this is this raga, or it may have multiple ragas within that. And then again, each one of them we can have, it's a kind of 2-dimensional array you can think of. And again, each note you can have multiple what do you call, like low note and high note, and so many other things, right? So again, we can extend it. So because of my limited knowledge in that area, I'm not going to say more about it, because I think the experts in that area can research on that, and they can learn something out of it. Now, coming to the next thing, how can we say Vedic mathematics is multidimensional? So many times, actually, multidimensional means we know 3 dimensions, X, Y, Z, usually we say, but 4th dimension also nowadays people know time is the 4th dimension, and then 5th, 6th, we can have multi-dimensional thing. And of course, this multi-dimension thing, we use it in many other aspects, like in spirituality and other areas. But the real meaning of multi-dimensional is like this. See, suppose if you take Ekadikena Purvena, this is one of the Vedic math sutras. Out of the 16, this is one of the sutra. Ekadikena Purvena. Eka means 1. Adikena, Adika means more. Ekadikena Purvena, the previous one. Purvena means previous one. So we have one more than the one before. That is the translation, you can say, closest translation. So using this formula, we can do multiplications like 76 times 74. If you want to do that multiplication, in regular way, it may take a little bit time, but generally, I mean, you can tell the answer, which is 4,200 and... Okay, sorry, I think you're all on mute, right? So you cannot answer, so let me answer it. 4,224. Sorry, it's 76 times 74, right? Yeah, it's 5,000, sorry, 5,624. That is what you get. Now, we can extend that to different things. See, in this case, actually, the base rule to solve this is like, the units place, some of the digits should be equal to 10, and then rest of the digit should be equal. So this is 2 by 2, but of course you can have 3 by 3, 4 by 4 multiplications. Then we can apply this as long as that rule works. Like 6 plus 4 is 10 units place, and then rest of the number should be same. So for example, if you want to find 791, 700 and okay, then let's see, 997 times 993, something like that. 997 times 993. In regular way, it takes so long, but 997, 993, if you take 7 plus 3 is 10 in units place, and then 99 is same for both the numbers. So we can apply that rule. So 99, the simple thing is like, you need to multiply units places. 6 times 4 is 24. You can write units and tens place 24. And then 7 times the next digit, which is 8. 7 8s are 56. So you get 5,624. That is the answer I took. But if you take 997 times 993, then 7 times 3 is 21. And then 99 times next number, which is 100. So you get 99 times 100, 9900. So 990021. Yeah, 7 3s are 21. 990021. That is the answer. So now if you take the expansion to that, we have 755 times 745. We can use it. How 55 plus 45 becomes 100. So if you take units place and tens place, and that adds up to 100. The rest of the number is same. So we can apply that. And similarly, we can use. Yes, sir.
The multiplication they are asking you to repeat again. Some of they have not repeated it, I think. The multiplication.
Multiplication, the top one, this one?
Yeah, that one and next one, because if do you have anything to show, like how you are doing it, you are explaining it, they are asking.
Oh, okay, I can show that, but otherwise, they can take a paper and pencil. I can tell what to do. Okay. If they do by themselves, that'll be more easier. Otherwise, let me see whether I can. Okay, like this. See, 76 times 74. This is what we are doing. Okay. In this case, the first step we need to see is 6 plus 4 units place. 6 plus 4. Oops. 6 plus 4 equal to 10. So that is the first condition. Second condition is 7 that is condition 2. So if those two conditions satisfy, what we can do is simply the first step is 7 times 8. Okay, this is one part. The left part is 7 times 8. Whatever number you have here, 7, multiply by the next digit. If you add 1 to 7, ekadikena purvena, that is the meaning. 1 more than the 1 before. This is the 1 before 7. And then 1 more than that, which is 8. So 7 times 8, that's what we are going to do. And then the second part is like simply multiplying 6 times 4. Like that. Okay, which brings up to 5, 6. And then here you get 24. 6 4 is 24. So 5,624. Hope I think this is clear for you. Okay. Similarly, I mean, we can extend the same thing for other. Okay. Okay, if you take this multiplication, 755 times 745, and this is the extension to that. 55 plus 45, if you add, you get 100. right? Here in this case, 6 plus 4, 10. That is the first condition. Here we can use the condition like this: 55 plus 45, 100. That is first condition. Second condition, 7 and 7 both are same. So the second condition is also satisfied. So now we can apply Ekadikena Purvena there. Okay, I'm not going to explain in detail that. Probably you can experiment at home and see, like, how it works. And similarly, if you take 902 times 998, if you take this is having 2 here, 0, 2 and 98. When you add these two, that becomes 100. And then rest of the number is same. So here also you can apply this. Okay, and then if you take this one, 8025 times 8975. In this case, 025 and 975. If you add these two, that becomes 1000. So we are taking units, tens, and hundreds place. And then when you add them up, you are going to get 1000. And then the rest of the number is same. So you can apply this. Okay, this is one dimension. Okay, we are expanding in one dimension. Let's see the second dimension also here. Okay, this is also the same, similar kind of category, 9901 and 9999. So if you take units and tens place, 99 plus 1, which is 100, and then rest of the number is same. So we can apply that rule. Okay. Now coming to the second way of doing
Can you
it.
please write the answers for them so that they will understand how you are doing it for those three?
Oh, okay, I can do that. Okay, let me. Oh, okay, let's take
Or we'll ask the
755.
kids to write their answers without doing the calculator.
Okay. Okay, 745. If you take this, the first condition is 55 plus 45, which is equal to 100. Okay, this is condition 1. The second condition is, we have 7 is same in both. Condition 2. Once we confirm the conditions are satisfied, next step is we need to take 7 times 8. That is the first part. 7 times the next digit 8. And then we put a pipe. And here actually is the important part. 55 times 45 need to do. 55 times 45. And then because we are multiplying 2-digit number by 2-digit number, we get 4 digits in the answer. Okay, if you get only 3 digits, you need to put a 0 there. Okay, that part we need to see. Now, for solving that, I use multiple other sutras. Okay, so 45 times 55 means I can take average method, one of them, which is 50 square minus 5 square. Because if you take 45, that is which is 50 minus 5, and 55, 50 plus 5. So if you take these two numbers, we can write 50 plus 5 and 50 minus 5, which is 50 square minus 5 square. 50 square is 2500. Okay, let me write it. 2500 minus 5 square is 25. Okay, if you simplify that, you get 5, 6, and then 2500 minus 25, you get 2475. So that is your answer. You can verify. Okay, similarly, you can try 902 times 998. Okay, let me do it. Okay, so that you can understand that. Here, actually, I'm not writing down the conditions because it's very clear. The conditions are satisfied because 2 plus 98, which is 100, and then 9 is same. So the answer is going to be like this. 9 times, next digit is 10. Next number is 10. So 9 times 10 is the first part. And then second part, we need to multiply 2 times 98. 2 times 98 is 196, right? 196. We cannot put 196 like that. We need to put a 0 before that. because we are multiplying 2 digit by 2 digit. It's supposed to have 4 digits in that. Does that make sense?
Yeah.
Hmm. Okay,
Maybe we
now
can make them to do some problem. Probably they will get to understand the. Someone asking the question, what if the 100th digit or 10th digit is not same? Because whatever we are showing here um, are having the same digit, right?
Right.
So
Yeah,
my
I got.
answer to them was, we are only confining with one sutra. What are all the problems can be solved? So
Right.
that is related to a second another sutra, right?
Right. So basically in Vedic math, we have some generic rules, generic sutras, and some of them are actually, specific to a situation. Okay, this is one specific situation we are doing. When the conditions satisfy, then only you can apply that sutra. Otherwise, you cannot. Okay, suppose if someone asks you, what is 75 times 75? 75 times 75. You can use this sutra because 5 plus 5 is 10 units place, and then 7 is common. So 75 times 75, it's going to be 5,625. You can directly tell the answer like that. Okay. So this is one dimension actually I'm going to show here. Can I erase this?
Sure. I think the anyway it will be there in the PowerPoint sheet.
Right. Okay. Let's see. Let me erase this. Yeah. Now coming to the next part here. So these things are also actually, a little bit, bigger numbers I gave there, but the same rule actually, the same way we can apply. Probably, I think I can send notes, in that shared folder. If you have any questions, you can post those questions, and I can answer them. Okay, good. Now coming to the other dimension. Here actually, we are checking for units place. Some of the units places is equal to 10, and then the rest of the number is same. If you take this one, this is exactly opposite. See here actually 6 plus 4 is 10. In 10's place, the sum of the digits is equal to 10. But units place, the number is same. So this kind of multiplication, we need to do in a different way. I'll show you how to do this. Maybe that's very interesting for you. Here actually 67 times 47. Condition 1 is 6 plus 4 equal to 10. Condition 1. Okay, next, the second condition is, okay, second condition, you can say, yeah, 7 is same. Units place. So this is second condition. So we, both the conditions are satisfied here. Now, how to solve this? So first step is actually we need to multiply 6 times 4. I'm writing it here, so just watch carefully, you can understand. 6 times 4, and then you need to add that 7, what is there in units place, and then put a pipe, and then you need to simply multiply the units places. 7 sevens are 49. So when you simplify this, you get 6 4s are 24 plus 7, which is 31. And then 49. So that is your answer. Is that clear? 67 times 47. Let me explain one more time. Here in this case, 6 plus 4 is 10 in tens place. And then 7 is same in units place. So those are the two conditions satisfied. Now coming to the solution.
Srinivas,
Yeah.
I request everybody, please do not do any scribbling or drawing on the board. It is distracting other people. They are not able to see the numbers. Please.
Yeah.
And the teacher has to erase them, and it will be wasting the time
Yeah,
as
it's
well.
actually you're missing something here. Like, it delays our time actually. It's already more than an hour. So
Well,
okay.
we'll be concluding at 9 anyway. Okay. So,
Yeah,
connect.
this 7 times 7 is 49. Units place, when you multiply, you get 49, that part. And then 6 times 4, and plus the units place number. That's what you need to add. So you get
Let's put one
3,100.
more problem and then have them solve and give you answer. Then maybe
Yeah, probably they can do this. 86 times. Okay, let me write it here.
everybody take the problem and see what you can do.
86
Times 46. Can we
yeah,
do?
you can say, no, you cannot say 46, but because tens place, we're supposed to have some of the tens place should be equal to 10, right? So 86 times 26, that's what you need to
26.
find.
Okay.
Yeah.
Okay. So 6, 36, and 8 into 8 plus 2, 10, 8 into 2, so 26, 36, right?
8 times 2, 16. Yeah, 16 plus 6. You
22.
get 22, right?
Yeah,
So, okay,
somebody
let
already
me,
put the number. Good
yeah.
job, Madhavi Gunapalli. Okay.
So let me write the answer. 16 plus 6, 22, and then 36. This is what you get. So that is the correct answer. So how many of them answered correctly?
Yeah, I think everybody gave them. One
Wonderful.
person gave wrong. That 7836 they said wrong. It is 2236 correct. Okay. Give one more problem, please, Srinivas.
Okay. Yeah, let's do this. Maybe I don't know whether they can see this. Okay.
So why did you add
90.
6 to it?
What?
8 into 2, 16, right?
And
8 plus 2 is 10.
Okay, let me tell you one more time. 54 times, say, 54. Yeah, we can do this. 54 times 54. Okay. Here, actually, when you see this particular pattern here, 8 plus 2 is 10 in tens place. And then units place, the number is same. So those are the two conditions we need to check for. Once those conditions are satisfied, simply 8 times 2, which is 16, plus you need to add that units place number. 16 plus 6, which is 22. And then 6 times 6, 36. Simply multiply units places and get 2,236.
So what is the answer for 54 times 54?
Yeah.
Anybody? I think they already gave 2916. 2916.
Yes, that's correct. 2916, correct.
So we have seen two patterns here. In one pattern, where you have the second 10th place numbers are same, and ones place numbers are totaling to 10. And we have seen the another pattern where ones place numbers are same and 10th place numbers summing up to 10.
Yes.
So two directions.
Yeah. So let me erase this part. Let's go further on this, and then so this is another question. 98 times 18, and then 999 times 19. In this case, actually, we have only 2 digits, so you can put a 0, 019, something like that. Okay, because if you take here 99 plus 1, which is 100, and then 9 is same, so you can apply that rule. Okay, in the first, in this one, it's very easy. 9 plus 1 is 10 in tens place, and then units place number is same, so we can use that, and then we can extend that to 4-digit number, 5-digit number. It really, easy. I mean, but you need to practice it. Otherwise, you may forget. If you just leave it for one day, you may forget it. So you need to practice at least for a few days, then you remember it forever. Now coming to the next sutra, Nikhilam Navataha Charamam Dasataha. Satishji, what do we do? This more than an hour already.
No, actually, we started at 7:45.
Mm-hmm.
So we can take another 10 minutes if we can finish up one of these.
Okay.
Then we can go for the next part tomorrow.
Okay, sure. Okay, this is another sutra, Nikhilam Navataha Charamam Dasataha. This is very, very interesting sutra. Many times, actually, when we have subtractions, like 10,000 minus 751. Okay, let me write it here. 10,000 minus 751. Let's say 1,000 minus 751. Okay, just I don't want to go for a complex one right away. So if you want to do that, usual practice is like, borrowing from previous number, and then again borrowing, and all that stuff is there, right? So which makes very complex. But the same thing can be done using this sutra, Nikhilam Navataha, that means all from 9 and last from 10. That is the rule. So if you take this one, 1,000, we have 4-digit number here, and this is 3-digit number. Okay, so in this case, actually, if you subtract 1 from this and subtract 1 from this, there is no difference as such, right? So for example, if you take 25 minus 7, which is 18, 25 minus 7 is 18. Suppose if you subtract 1 from each, 24 minus 6, which is also 18, 23 minus 5, which is also 18. So if you reduce 1 from both minuend and subtrahend, both, you subtract 1, the value is going to be same. So instead of doing 10,000 minus 751, I simply write 999 minus 750. Both are same. So if you do this way, you need not actually borrow, you need not to do any complex things there. Simply you can write the answer 2, 4, 9. That's it. Simple. 2, 4, 9. Okay. This is how we can do it. So the same thing is given in a rule, Vedic Math Sutra, or you can say rule. In this, it says all from 9, last from 10. Nikhilam Navataha. Nikhilam means all. From Navata. Nava means 9. So Navataha Charamam, last one. Charamam means last one. Dasataha, from 10. So if you use that, in this 751, all from 9, right? 9 minus 7, if you write 9 minus 7, which is 2, and then 9 minus 5, which is 4, and then last one from 10, 10 minus 1 is 9. So that is how you get the answer. So you need not do, complex subtraction there. It's going to be much, much easier that way. Okay. So we can apply this rule in different, scenarios. I'm going to show you those scenarios now. Because I can explain these things in detail and you can practice it, but maybe I can send you some worksheets. You can practice and you can understand. That way, we can spend more on other expansions for this. Now coming to the next thing. Okay. And let me tell you this. This is very interesting thing. In my childhood, actually, I used to do subtractions in a different way. And I always used to get 0 marks in mathematics. I'll show you how I used to do it and how we can improve it using Vedic mathematics. Okay. This is the subtraction. Okay. So this is what you need to do. Can you do it yourself and keep the answer ready?
Without doing it, you just have to put the answer.
Yeah, you can just keep the answer ready. I mean, you need not put it in chat box. Okay, it's not required. But keep the answer ready. I'll tell you what to do. Okay, let me explain this. Okay, in my childhood, actually, I used to do this subtraction like this. I used to put the answer 124. I think all of you are laughing at me, right? See, 124, I used to do this, like, I cannot subtract 6 from 2. So I used to simply subtract 2 from 6 and put 4. And I cannot subtract 5 from 3. So I used to subtract 3 from 5 and put 2 here. And then 2 minus 1, oh, it's easy. I used to put 1. So this is how I used to do. And naturally, I mean, I used to get 0 marks. Okay, this is wrong. So how to correct it? Simply, whenever I'm subtracting from bottom to top, like, minuend from subtrahend. Whenever I'm subtracting the top number from bottom number, I put a bar on that. Okay. In this particular 2 digits, like 2 minus 6, I use 6 minus 2. So I put a bar. And then 5 minus 3, instead of 3 minus 5, I did 5 minus 3. So I put a bar. So this is what I did. So I got 1, 2, 4 bar. This is what I got. Now I use Nikilam Navataha Charamam formula. Okay, when I do that, simply all from 9, last from 10, right? So if I do, 1 anyway, 1 and this is bar, kind of negative number, right? So you can ignore this 1. And then 2 from 9, 9 minus 2, which is 7. And then here you have 10 minus 4, 6. that is what we need to do. And we get 76. That is the answer. Did you get it? I think most
Not
of you got
really.
the answer,
I
right?
think kids need to do it again. And
No, they already calculated, right? They already calculated and kept the answer ready.
yes, but they need to use the sutra and then apply it.
Yeah. I'll tell you one more time, okay?
We will learn this one perfectly, Nana. Then we will be taking a break for next session. Okay, so let's all focus on it.
Okay, see, this is how I used to do. I cannot subtract 6 from, I think someone is...
Request again, people are just scribbling on the board. It's not good.
Okay, 6 I cannot subtract from 2. So I used to subtract 2 from 6. And then similarly, 3 minus 5. I cannot do that. So I used to do 5 minus 3 and put 2 there. So I got 1, 2, 4, which is wrong. Okay, which is wrong. So what I did, I put a bar on the numbers where I subtracted the top number from bottom number, wherever. So 6 minus 2 is 4, so I put a bar. And 5 minus 3 is 2, I put a bar. And then this one is 1. Now, whenever you get this kind of thing, you can ignore this one. Okay. I mean, if I go in detail about the sutra, probably I could have told why we are ignoring this one. But right now, I think just remember that, ignore that one. And then 2, 4, we need to apply Nikilam Navataha Charmam Dasita, all from 9, last from 10. So 9 minus 2, which is 7. Okay. 9 minus 2, which is, okay, here. 9 minus 2 is 7. And 10 minus 4 is 6. So that is your answer. Okay, let's see another example here. There is another example, I guess. Yeah, if you take this one. Okay, you can note down the numbers and you can try it. You can try to find answer, and I can explain immediately after that.
People are playing game. It doesn't look like. I'm erasing it. People are drawing it again.
Okay, now let me show you. This is the answer I got. Because I cannot subtract 5 from 4, I subtracted 4 from 5 and put 1. And here also the same thing. In this case, okay, it's easy. 7 minus 3 is 4, I put 4. And in this case, again, the same problem. So I subtracted 3 from 6. And here also I subtracted 4 from 5. And the last one, I put it the right answer there. So finally, I mean, this is the wrong answer. So I use Nikilam Navataha Charamam Dastaha. I'm repeating the Sanskrit sutra because I mean, if I tell many times, probably you may catch that phrase and you can remember it. Otherwise, I mean, if you translate, the closest translation is all from 9 and last from 10. So when you do that, so I put bars on those. Because 7 minus 3 is 4, we directly did it. So I'm not putting bar there. But if you take 4 minus 5, I put a bar. And 8 minus 9, which I did it in reverse way, so I put bar. And here also the same thing. So this is what we got. Now, applying the rule, here actually we need to reduce by 1. Earlier 1 is there. So when you reduce by 1, it becomes 0. That's why we ignored it. In this case, we have 3 here. So we need to reduce by 1. We get 2. And then we have 1 and 3. We need to use all from 9, last from 10. So 9 minus 1 is 8. And 10 minus 3 is 7. So you got 2, 8, 7. And then this 4 is there, but we have a bar number after that. So we need to reduce this by 1. You get 3. And then here we apply all from 9, last from 10. So 9 minus 1 is 8. And 10 minus 1 is 9. So this is your answer. So did you get the answer? All of you, I think probably you might have got the same answer. So once you are comfortable with this, you can, teach your kids like this. But the problem is like, make sure the school system, many places, they're not accepting, doing this way. So yeah, this should be an alternative way for them at least. And that way, they don't feel mathematics is complex. Otherwise, borrowing and all that, sometimes, they feel a little complex and sometimes they give up learning mathematics. Okay, again, Satish, I'll skip some of these things. Actually, multiplication by 9 series, this is also the same. We can use Nikilam Navataha formula here also. Just I'll quickly show that, and then I'm not going to explain much on this. Suppose if you are multiplying
kids,
these.
one second.
Yeah.
Hope kids or somebody who is participating has little manners to understand what teacher and host is requesting you. Please do not do any drawings on the page. I'm trying to clear it every second you are drawing again. If you do not like to sit in the class, understand it, you can exit. We are not asking you to stay back. Please, thank you.
Okay. So if you want to multiply this thing, it looks so complex, right? So, okay, I wanted to tell you something here. Many times, actually, when you see a question in mathematics, I think many of the students, they immediately mute their, thinking. Like, oh, this is complex. So they don't even try. But this one, I'll tell you how easy it is. How easy it is. It can be done within, mentally you can answer this. Okay, I'll tell you how to do that using this Nikilam Navataha formula. And then, this is a specific pattern, like, whenever you're multiplying by a 9 series like this. Okay, the number and 9 series, the digits are same in this case. If the digits are different, probably we can do that as well. But I don't want to tell those things here because of time limitation. But down the line, we may do more sessions and I can explain each and every one clearly. Now, the first step is like, write down this number, just subtracting 1. get 548733. Okay, the top number other than 999999. This number, take this number, subtract 1 and put this number here. That is left part of the answer. And right part actually simply we take Nikilam Navataha Charmam Dasta. All from 9, last from 10. Simple. So now we have 9 minus 5, you get 4. 9 minus 4, you get 5. 9 minus 8, you get 1. 9 minus 7, you get 2. 9 minus 3, you get 6. And then last one from 10. 10 minus 4, 6. So that is what you are going to get. See here. 9 minus 5, you get 4. 9 minus 4, 5. And then 9 minus 8, 1. And 9 minus 7, which is 2. And then 9 minus 3, which is 6. And then 10 minus 4, which is 6. So this is your answer. One step. So if you can remember those 6 digits, you can tell the answer mentally without using paper pencil. That way. Okay, this is another application for Nikilam Navataha Charamam Dasta. Okay, let's see the next things. Anyway, you're going to get this information maybe through email or something, or maybe in shared documents. So I can provide some more details on this. Now coming to this sutra, this is actually vast knowledge you can gain from this. It's very widely used. I think many of you might be using it. Multiplication. Okay, simply, if you multiply 43 times 65, we can use this rule and you can tell it in single step. I explained it in a clear way, step by step. First, we need to multiply unit places like this, get 15. And then we multiply crosswise like this, and then add them. You get 4 5s are 20, and 6 3s are 18. 20 plus 18. That is second step. And third step, again, vertically, 6 plus 4, 6 times 4 is 24. So this is what we got after step 1. And then we write 5 as it is. And then this one.
Yeah. Past 9 kada, so maybe this one is very important for them to learn, so we can.
Yeah, maybe we can do it, next session sometime. So this is how, we can extend that. Okay, let me. And this is actually, explained in a different way using,
we learn this sutra tomorrow. How about we start sharp at time and we'll do it because it's already past 9 now.
Okay. So yeah, I think I'll skip all this. Yeah, we can use it in algebra, geometry, and other places. Okay. Tomorrow, shall I do this, Satishji, or do we continue that?
We'll just tell them what we are going to learn it. That other one, the crosswise vertical, and also we learn this one, right? Yeah, go ahead. Please let them know, and we'll close it out.
Okay, tomorrow I think we can continue on vertical and crosswise that sutra, and then we can have some fun stuff here. Like, if I give this number 7744, what is the square root of it? Can you tell right away? Seeing that, I'm going to explain certain things like that. I can answer some of the questions if you calculate square of a number, and if you tell me, I can tell the square root. And these are the other topics actually I'm going to answer tomorrow if you are interested. Now coming to the last part of the session, I have a question here. Okay, if anyone, one of you want to try, you can practice it. You can try it and keep the answer ready for tomorrow. How to find the value of A. Okay, the question here is 2 power 64 minus 7 is equal to the number given here, 1, 8, 4, 4, 6, 7, and so on. And there is an A here, alphabet A. So you need to find the digit, what digit you can replace A with. So that
everybody, please note down this problem. So this is a problem for you all to think of how you can solve this. 2 to the power of 64 minus 7. And he gave the full number and he is missing only one digit, which is there as A. So you need to tell what is the value that can be fit into the A. Okay. So it's not like a homework for you, but it's just, thinking for your brain. Somebody is already giving the answer, Srinivas.
Oh,
Yeah, but
okay.
I don't want to disclose it
So
here.
what did they answer? Okay, don't tell. Okay,
Yeah,
let's
yeah.
see later.
Okay. Okay, everybody. Shall we? Yeah, we started a little late. That's why we could not able to finish up the material what we wanted to cover it. But eventually, you're going to learn this tomorrow. You just be here sharp 7:30. Everybody, and end of the session tomorrow, we are going to give the information about the slides. We are going to send you the slides link, and also we are going to provide you the books information many people are asking about. And thank you so much for Srinivas to uh, give the introduction about Vedic math. And we are really excited to learn the other techniques which you mentioned in the last page. So let's all come in time and do it. Okay. So let's do the prayer and the concluding it.
Thank you, Satish.
Om Agnenaya Supataraye Asman Viswani Deva Vayunani Vidwan Yuyodhyasmadjuhuranamenah Bhuishthante Namavuktim Videma Om Purnamidam Purnamadaha Purnat Purnamudachyate Purnasya Purnamadaya Purnameva Vasishyate Om Namah Paramarushibhyo Namah Paramarushibhyah Om Namah Paramarushibhyo Namah Paramarushibhyah Om Asmadgurubhyo Namah. Jai Simanaran. Everybody stay home, stay safe, and we see you all tomorrow. Okay, we are closing the. Okay, na Srinivas?